वेलकम टू एजुकेशन वर्ल्ड। तो आज का ऑनलाइन केमिस्ट्री क्लास में सभी को स्वागत है। और हमारा जो टॉपिक है वो ऑर्गेनिक केमिस्ट्री है। तो उसी में हम पढ़ेंगे आज हाइड्रोकार्बन। तो इसमें हाइड्रोकार्बन क्या होता है तो हमने पहले वो डिस्कस किया था। तो और एक बार इन ब्रीफ, so we are explaining things. So basically hydrocarbons means the compounds are, so compounds that are made up with hydrogen hydrogen and carbon। तो वो है हाइड्रोकार्बन। तो जनरली जो हाइड्रोकार्बन का मतलब क्या है, जो हमने जो कार्बन और हाइड्रोजन से जितना कंपाउंड मिलते हैं तो उसको बताते हैं, तो हाइड्रोकार्बन। ठीक है। तो हाइड्रोकार्बन अगेन वी हैव सीन, सो बेसिकली इट इज अ टू टाइप्स, सैचुरेटेड अनसैचुरेटेड। आई एम नॉट गोइंग द डिटेल्स। अगेन सैचुरेटेड कुड बी वी कॉल द एल्केन्स, okay, the alkane, and the unsaturated can be divided into two parts, so that is alkene and alkyne। ठीक है। तो ये जो है दोनों, ये है अनसैचुरेटेड, टी यू आर ए टी ई टी, unsaturated, and this one is saturated hydrocarbon, saturated hydrocarbon, and these two are unsaturated. So so saturated means, so basically these alkanes are saturated with the hydrogen, so you cannot add another extra hydrogen। तो इसमें जो होता है, जो हम इसमें और ज्यादा हाइड्रोजन इसमें ऐड कर नहीं सकते। ठीक है। लेकिन जो एल्केन और एल्काइन है, इसमें और भी हाइड्रोजन एकोमोडेट कर सकते हैं। तो हमने जो देखा था, तो ये जो है एल्केन का जनरल फॉर्मूला क्या होता है, वो होता है CnH2n+2। okay, so this is the general formula of alkane. And what about the alkene? So this is a CnH2n, this is a general formula or empirical formula of alkene। तो ये जो है, इसमें है अल्काइन क्या है, तो इसमें CnH2n-2। so this is the general formula of alkyne। तो ये जो स्ट्रक्चर से जनरल फार्मूला और द एम्पिरिकल फार्मूला से क्या पता चलता है, यहाँ पे जो इस जो मॉलिक्यूल है, इससे 2 हाइड्रोजन इसमें कम है और इसमें 4 हाइड्रोजन विथ रिस्पेक्ट टू एल्किन एल्केन ये कम है। ठीक है। तो ये जो हम इसका एग्जांपल लेंगे, तो इसमें क्या होता है एक्चुअली, द बेसिक डिफरेंस बिटवीन दिस, सो एल्केन it is a normal hydrocarbon, and this is the alkene, it is a hydrocarbon which are having 2 hydrogen less compared to the alkene. So basically here we are having one CC double bond, at the same time, so we are having one triple bond, carbon carbon triple bond। because of that, so यहाँ पे क्या मिल रहा है, जो 4 हाइड्रोजन लेस है। तो ये है, हम जनरल जो एग्जांपल लेके हम इसको समझेंगे क्या है। तो ये जो है एल्केन, एल्केन क्या है, तो इसमें ये है जनरल प्रॉपर्टी। सो हम यहाँ पे n=1 ऐसे पुट करेंगे, तो क्या आएगा CH4। तो इसको हम जानते हैं, इसको बोलते हैं मीथेन, मीथेन। so we know the name of this, so basically this is a methane, and if we put n=2, so basically this will be ethane C2H6। okay, so this is our methane and this is ethane. So like that we can put the n value, and n to 1 2 3 4 5 6 and up to n. So basically we know that because of the catenation properties of carbon, so it can form a long carbon carbon chain, so maybe up to 100 also we can put in equal to 100। so basically this will be our hydrocarbon or the alkane। But when we this is a general formula. This is a general formula of alkane, and now because of n value we can have different alkane. And for this series we have to remember. So this is a first member of the alkane. So basically, this is again we can talk about we learn about the homologous series. So here we can see these two molecules are differ by only CH2 unit. Okay, so because of this, so basically all this will be a homologous series, and in this homologous series, so the first member of this alkane is methane. So this is a kind of a sometimes people used to ask what is the first member of your alkane family. So this is your the option. So is the same way when we'll talk about alkene. So basically alkene means so at least it has one CC double bond. So for the CC double bond, so we cannot put n equal to 1. Okay, so n equal to 1 if we put, so we are having only one carbon. So one with the one carbon double bond is not possible. So for this one at least you have to put alkane n equal to 2. So for n equal to 2, so then the structure will be C2H4. So this is again the first member of the alkane. This is the first member, or yeah, first member of alkene family. So in the alkene family, so this is the first member, whereas in alkane, so methane is the first member. Okay, so this is now again if we can put n equal to 3, 4, and so on. Okay, so this is the first. So if we put n equal to 3, so basically then it will be like a C3H6. Sorry, this is differ by CH2 unit. So they are homologous series. Okay, Minu Saini, good afternoon. Uh, Again, so hope you are enjoying the class. So again, this is no differ by no CH2 unit, and these are no all you can say the homologous series. Okay, so again in this alkyne what we are having CC triple bond. Again for the CC triple bond, we at least we need two carbon atom. So basically the first member of the alkyne, it should be n start with the 2. If it is n equal to 2, so basically then it will be like a C2H2. So this will be again the first member. This is the first member of of alkyne family. Alkyne family. Okay, so this is how we can learn about the alkane, alkene, and alkyne. So we'll learn in details about all these things. So now we are having brief idea about the alkane, alkene, and alkyne, and they are the first member of this homologous series. Okay. Now let's talk about just alkane. So basically now alkane can have different. So basically now we'll start with the alkane, and slowly we'll learn about the nomenclature. So basically now alkane in the alkane, so this is the general formula CnH2n plus 2. So this is if we put like this, so CH4 C C2H6 no C3H8 C4H10, and it will go so on. So basically but now then we should have a name for this one, and instead of no normal name, so basically we'll go for the IUPAC nomenclature. So basically this is called the IUPAC. So this is the short form of the name. So basically this is international inter international union of union of pure and applied chemistry. So these are the full form of IUPAC. So basically, this is the international convention. Based on that, so basically we can give a name to this and all this to understand. So basically, to give a IUPAC name. So this is the different on some method we learn this one. So for this to give a name or so basically we need the root word. So this is the method is like this. So basically we will have a root word, then we are having like a suffix. So suffix, and we will have the prefix. So prefix and suffix, so basically these are the main, the system. So basically how to give a name for a organic compound. So the root word, it depends on this is the root word, it came for the number of carbon atom present in the molecule or compound. Okay, so this we learn. So basically, the depending on number of carbon atom, what we'll call. Then suffix. So basically, suffix, it it can be again divided into two parts. So basically, the primary suffix and then secondary. So again, it can be divided into two parts. So primary suffix, actually it talk about the functional group present in the molecule, or the double bond or triple bond present in the molecule. So if it is a the primary suffix, again it can be, so basically the primary, and this is another is secondary. तो सेकेंडरी क्या है, तो इसमें जो होता है ये फंक्शनल बिकॉज ऑफ द फंक्शनल ग्रुप. So if the molecule, if the functional group present here in the molecule, so then the secondary suffix will come. If there is any double bond, if there is a double bond, CC double bond or CC triple bond, so that will come as a primary suffix. तो इसमें क्या है, जो हमारे पास इसमें फंक्शनल ग्रुप, कंपाउंड में फंक्शनल ग्रुप कोई नहीं रहेगा, तो उसका जो सेकेंडरी सफिक्स नहीं आएगा, उसमें कुछ डबल बॉन्ड ट्रिपल बॉन्ड नहीं रहेगा, तो वो जो सॉरी दिस इज सेकेंडरी सफिक्स नहीं आएगा, ये जो डबल बॉन्ड और ट्रिपल बॉन्ड नहीं रहेगा, तो इसमें क्या होगा, प्राइमरी सफिक्स नहीं रहेगा. और मतलब डबल बॉन्ड और ट्रिपल बॉन्ड और फंक्शनल ग्रुप कोई भी नहीं रहेगा, तो इसमें क्या है, ये जो पूरा सफिक्स है नहीं रहेगा. और प्रेफिक्स क्यों आता है, दिस इज because of the substitution. So basically if we have a halogen substitution, so halogen substitution, halogen, or if we have a two functional group, so then priority basis the primary will be the primary functional will go to the end, and the secondary will come to, that will be different. So basically here for the time being, all the branching or the basically substitution 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 those substituted the functional group or the the species halogen, those will come. So we'll take an example how halogen it will act as a substitution, and how we can put in the prefix. Okay, but the most important thing is that, so we have to remember the root word. So the root word, it will come from the number of carbon atom present in the molecule. Then suffix because of the double bond or triple bond, this is primary suffix. And secondary suffix, it will we have to use if there is any functional group. Okay, so with this model, so basically the prefix, root word, suffix in this model, so we'll try to learn the how we can know the name of an organic compound, or we can give a name of organic compound. Okay, so the root word can be generated like this. So basically this is your number of carbon atom. If we are having, this is a number of carbon atom, number of carbon. So if you are having one carbon atom, so then the root word will be the meth. Okay, if we are having, this is the number of carbon atom, so if we are having 2 carbon in the compound, so then it will be eth. If we are having 3 carbon atom, then we are having prop. Okay, so this is the convention. It is given by the Iupac. So you are having the 4 carbon atom. So if we are having 4 carbon in the compound, so then we are having the name but. Okay, if we are having 5 carbon in the compound, so then the root word will be the pent. Okay, so if we are having 6 carbon in the compound, so then we'll have hex. Okay, so they, if we are having 7 carbon, then we are having hept. If we are having 8, so then we'll have no oct. And 9, so this is the no. So these are the these are the names. So basically these will be our root word. Okay, so the root word for the depending on the number of carbon, so this will be our the root word. Okay, so now, yeah, so you can Harjit, so allotropes, I think we discussed in the previous class. You can go and look back those video. So basically this is the different form of any different form of any species that present in a same state. So you can look at the previous video, and you can have a idea about the allotropes. Not only allotropes, we discuss about their properties and things like that. Okay, so this is now we are learning how to do the nomenclature of this topic. Okay, so in this topic, so basically now these are the root word, and you can have, let's take an example how it would be the name for the alkane. Okay, uh, for the alkane, so as we learn, so basically alkane, so this is the general formula, CnH2n plus 2. So this is the general formula. Now we are putting, so basically if we having as CH4, so basically n equal to 1, so then the root word is meth. So actually for the alkane, so from the name, so basically this is this is the suffix, it will come the root word meth n. Okay, so this is ane, so that is for the alkane. Okay, so now if you put like this, so basically if we are having C2H6, so then it will be the name of the compound will be the eth n. Okay, so now if we are having 3, so basically C3H8, so then it will be like a pro n. Okay, so and so on, you can add ane if it is a normal hydrocarbon. So if it is a normal hydrocarbon, you can normal or alkane, so you can do like this. Now again we will talk about the alkene. Okay, so एल्किन एल्किन इसका जनरल फार्मूला क्या है? इसका जनरल फार्मूला जो है CnH2n. And what we remember, we told, so basically the first member of the alkane series, it will start n equal to 2 because there is a double bond. So then it will be C2H4. This will be the first member of the alkene family. Okay, so this is like we are having C2 carbon, then the name of this, so this will be eth, and the n, so this is because of the double bond, so basically this will be ethane. Okay, so the same like eth word, root word is in, so here our no suffix is no in. So again here the root word, so basically we are using for this case for the alkane, so root word plus ane, and here root word plus ene. Okay, so this is ethane. So similar way, if we put like a C3H6, so this will be propene, propene. Okay, so again, if we are having the C4H8, so that will be, we are having no but this is the root word, then we will have in. So these are the suffix. Okay, so this is the root word, so root word, and this is, we call, this is the primary suffix, as we discussed, primary suffix. Okay, this is how we can know, talk about the, alkane and, uh, alkyne. Alkyne having general formula CnH2n minus 2. So this is the general formula. Again, we learned, so basically for alkyne, the first member, it start with n equal to 2. So basically, will the first molecule, we are having C2H2. So the name, so this is the 2 carbon, the root word. So again here the root word, it will be root root word root word plus YNA. So this is the name of the alkyne. So if we are having 2 carbon, so basically this is eth. So ine, this will be the suffix. So basically this will be the ine, ethine, or the most commonly. So along with this, I hope you know this is the common name is, acetylene. Acetylene, this is a common name, and we'll frequently will use what is acetylene. So ethine is the IUPAC name. Okay, now again the same way, if you can take the another example like a C3, no, then H4, that will be your propyne. Okay, this is your propyne. So means you are having 3 carbon in the compound, and ine means 1, no, triple bond, CC, triple bond. Okay, so again the same way we can have, no, butene, and so on. So we can basically, you can take the root word, and depending on the number of carbon atom, so basically you will have a root word, and you can add the suffix, and depending on the what kind of, bond is present, whether it is a saturated, it will be ane. If it is if it has a double bond, so that will be ene. And the for uh, the alkyne, we are having triple bond, so basically this will be YNA. So these are the, again we'll understand in detail. And the previous class, I think we talked about the isomerism. So basically, if we are having the 6 carbon atom, so basically this is CH3, CH2, CH2, CH3. So this is also we learned. So this is a condensed formula. In this condensed formula, so basically we write all the hydrogen atom attached to the carbon all together, and we'll see the only carbon-carbon bond. So here we are having no 4 carbon. So basically the root word is but, and there is no double bond. So basically this will be butane. Okay. So now in this case, so this is the what is the formula for this? So basically the general formula for this one, we are having n equal to 4 cn. So basically C4 and H, so 10. Okay. So this is our general formula, and we can represent like this. So this is called the butane, and we call the n butane because this is a normal butane. Okay, so this formula again we can write like this. So basically this we can write, this is like a CH, CH3, and CH3. So this is also we are having now 4 carbon, but now arrangement is different. So basically then in the isomerism we learn about this. So we are having no the same formula, general formula, but the structural arrangement is different. So that is because of that, so that will create the chain isomerism. So this is a chain isomerism, example of chain isomerism. Okay, so in the chain isomerism again, so this is we can say the butane because it is having 4 carbon and there is no double bond, we can say butane. But what would be the compound of this? Okay, so for this actually we need to do the numbering. Okay, so we can do like this. So basically 1 2 3. Okay, so this is called in the 2 position we are having one methyl branching, so we can call it like this. So basically we are having total, even though we are having 4 carbon, so basically 3 carbon in a line. So that is why we'll say the at 2 position the methyl substitution. So क्या है इसमें, we are having 2 methyl prop n, ठीक है। तो इसमें क्यों है प्रोपेन, क्यों है, तो हमारा जो एक्चुअली इसमें हम अभी पढ़ेंगे जो क्या है, ये जो नोमेनक्लेचर करने के लिए हमारा क्या है, सबसे जो लॉन्गेस्ट चेन होगा तो वही को ढूंढना होगा. So we'll learn like this. We'll take another example. So here you can learn. So just take an example like this. So basically this name will be according to IUPAC convention. This will be 2 methyl. So this is pro n. So यहाँ पे ये जो बोल रहा है, सो हमने बताया था जो सब्स्टिट्यूशन के बारे में. तो ये जो है 2 पोजीशन में ये जो मिथाइल सब्स्टिट्यूट है, मिथाइल क्या है, जो मीथेन से कोई भी एल्केन से, जैसे हाइड्रोकार्बन जैसे है, कुछ कोई भी हाइड्रोकार्बन है तो उसमें एक हाइड्रोजन निकाल लेंगे. तो बेसिकली दिस इज योर हाइड्रोकार्बन इफ इट इज RH. So this is your representative hydrocarbon. So if you remove one hydrogen from this one, so basically if you are having R like this, so it can bond anywhere. So that will be like a alkyl. Okay, alkyl, alkyl group. So then methane, from methane we are taking out one hydrogen. So basically that is the methyl, methane to methyl. So here 2 position we are having methyl group. That is why we call the 2 methyl pro-N. Okay, and they are related each other as a chain isomerism because they are having the same molecular formula, but the structural arrangement of this, the group or atoms are different. So that is why they call the chain isomerism. Okay, so again we can take another example. So CH3, CH2, CH2, CH3, CH2, CH3. तो इसमें कितना कार्बन है, तो यहाँ पे जो है ये 5 कार्बन है. तो हमारा जो रूट वर्ड क्या आएगा फॉर 5 कार्बन. सो वी आर हैविंग पेंट एंड दिस इज देयर इज नो डबल बॉन्ड ट्रिपल बॉन्ड. सो दिस इज a normal alkane and it is having a general formula C5 then H12. Okay, so this is the general formula of this alkane and we are calling the first, it is called the pentane. Pent, this is the root word and the n, so this is your suffix and this is the compound is pentane. Now again for this we can have a chain isomerism. So basically we can draw the structure like this. So this is CH3 CH3 CH2 CH3. So again for this you are having the general formula. Again we can write like this. So now, so in the first in the example here, so basically we count like this. So basically wherever the way you go, so basically this will be the number 2 carbon. Okay, but for this it is different. Okay, for this it is a normal pentane, but for this numbering is difficult because if we go like this, so 1 2 3 4. Okay, and if we go like this, so if we have 1 2 3, okay, so again we can take this is the simple the same. This is like a CH3 CH CH2 CH3. This is our CH3. So basically if we start with this one, 1 2 3, so we can go this way 4, and this way if we go, that will also give 4. Okay, so now which numbering is correct? Because previously we see, so basically the either way if we go, so that there won't be any change, but for this case, so this is the, like if we go from left side, so this is like now our methyl. If you consider this one, so basically the first rule is we have to find the longest chain carbon. So for this considerations, basically this one cancel, and for this is the same, so basically either one you can keep. Okay, so now we are having two possibilities. We can go from left to right or right to left. So which one is applicable? So for this, so first rule is no, the first rule is the first, the maximum 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 carbon chain length. तो ये जो रूल है, फर्स्ट रूल, कोई भी कंपाउंड मिल जाएगा तो वो ड्रॉ करके उसमें क्या है, जो लॉन्गेस्ट चेन होगा वही चेन कंसीडर करना होगा, जो शॉर्टेस्ट चेन आएगा तो उसको कंसीडर नहीं करना है। सो मैक्सिमम चेन लेंथ और द पेरेंट चेन, इसको इसको बताते हैं, जो पेरेंट चेन वो सबसे लॉन्ग होना चाहिए। ठीक है, तो उसमें क्या आएगा, तो ये अभी टू पॉसिबिलिटीज है, तो इसमें हम लेफ्ट साइड से काउंट कर सकते हैं और राइट साइड से काउंट कर सकते हैं। लेकिन यहाँ पे क्या होगा, ये जो पोजीशन है जहाँ पे जो सब्स्टिट्यूशन है, तो उसको सबसे कम नंबर देना होगा, तो वो इसको बोलते हैं लोकेटेंट वैल्यू, लोकेंट वैल्यू, लोकेंट कार्बन और लोकेंट वैल्यू। तो ये क्या होना चाहिए, लोकेंट वैल्यू, ये नो मिनिमम लोकेंट वैल्यू, मिनिमम locant value. So if we want to now count the number, basically 1 2 3 4, तो यहाँ पे जो हो रहा है, ये जो मिथाइल ग्रुप जहाँ पे सब्स्टिट्यूट है, यहाँ का कितना नंबर मिल रहा है, 2 नंबर मिल रहा है, और यहाँ पे कितना मिल रहा है, वो 3 नंबर मिल रहा है। वो दैट मीन्स सो द मिथाइल ग्रुप एट पोजिशन इज एट 3 कार्बन, हेयर इट इज ए 2 कार्बन। So here our rule number no 2 is, so basically we have to find the lowest locatant value। ठीक है, तो जब सब्स्टिट्यूशन आएगा उसमें क्या होगा, जहाँ पे जो सब्स्टिट्यूशन है उस कार्बन को सबसे कम नंबर देना होगा, वो गिनती करने का टाइम। जैसे विल काउंट द नंबर, सो बेसिकली दैट कार्बन शुड कंटेन और शुड नो हैव द लोएस्ट नंबर। तो ये जो है, तो ये करेक्ट नहीं है, तो ये जो है यहाँ पे 3 ये है कार्बन नंबर है, तो ये करेक्ट नहीं है। जो नंबरिंग, जो एक्चुअल जो नंबरिंग होगा, तो ऐसा होना चाहिए जहाँ पे जो सब्स्टिट्यूशन है, तो वो, और जो ब्रांचिंग, सब्स्टिट्यूशन और ब्रांचिंग कोई भी बता सकते हैं, तो वो क्या है, मिनिमम नंबर मिलना चाहिए। तो अभी क्या है, तो अभी इसका जो नोमेनक्लेचर कैसा आएगा, तो ये जो आएगा, तो पहला क्या है, टू पोजीशन वी आर हैविंग मिथाइल, so basically the prefix we have to write first the substitution, so basically this will be 2 methyl, 2 methyl, then root word will be how many carbons we are having, हमारे पास 4 कार्बन है, तो ब्यूट, ब्यूट, एंड द suffix will be n, because इसमें कोई डबल बॉन्ड ट्रिपल बॉन्ड नहीं है, तो दिस इज वी कॉल्ड द 2 मिथाइल ब्यूटेन। ओके, तो इसका और भी पॉसिबिलिटीज है, हम देखते हैं और क्या पॉसिबिलिटीज हो सकता है। तो ये जो है ऐसा सिंपल, द सेम फॉर्मूला वी कैन राइट लाइक दिस, CH2 sorry, this is CH2 CH2 sorry, this is not CH3। तो ये जो आएगा, तो ये क्या है, ये भी सेम आएगा, जैसे ये जस्ट पोजीशन, सो पहले ये वाला कार्बन में था, अभी अभी ये भी है, तो हम जस्ट वी कैन डू द रिवर्स, सो बेसिकली वी कैन काउंट लाइक दिस, फ्रॉम वी कैन स्टार्ट फ्रॉम दिस वे, दिस 2 3 4, So it will give us the same compound like we got in the previous one. So it is not like that always you have to start from we have to start from the left. You can depending on, so basically the substituted carbon और जहाँ पे substitution है तो उसको सबसे कम नंबर देना होगा जितना पॉसिबल हो सके. तो इसके लिए क्या होगा, तो यही तरीका है. तो इस साइड से हम काउंट करेंगे तो इसका कम नंबर मिलेगा. ठीक है. Again we can take like this. So for example we can also the common name frequently we'll use. So basically if we are having this kind of substitution basically at the end, so CH3 CH3, तो ये जो ग्रुप रहेगा तो इसको बोलते हैं आइसो ग्रुप बोलते हैं. तो आइसो के साथ साथ जितना टोटल जो कार्बन है तो उसको साथ जुड़ा जाएगा. जैसे इसका कॉमन नेम है आइसोपेंटेन, ये भी बता सकते हैं. लेकिन जो यूपेक कन्वेंशन जो है तो वो रहेगा 2 मिथाइल 2 मिथाइल 2 मिथाइल ब्यूटेन. ठीक है. I hope you understand this, and we'll take another example and we'll end with this one. So basically we'll take another example where we can take like the more carbon. So basically CH3 CH2 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 CH3. तो हमारे पास अभी कितना कार्बन है, टोटल 6 कार्बन है. तो according to UPAC convention, so basically this is our general formula for this hydrocarbon is C6 H14. ये है जनरल फार्मूला. तो ये जो जनरल फार्मूला इसमें हम ये जो कंपाउंड मिला है तो इसका नेम क्या रहेगा, तो ये है 6 कार्बन. सो देयर इज नो सब्स्टिट्यूशन नथिंग, दिस इज ए लॉन्ग चेन. सो वी कैन just use the root word. So basically hex and then n is the suffix because there is no double bond, no triple bond. Okay. So this is, now we can again we can do the substitution, we can arrange this one. So basically we can have like a CH3 CH CH3 CH2 CH2 CH3. तो इसमें क्या है, तो हमारा जो वो जो लोएस्ट लोकेटेड वैल्यू बताया था तो उसमें क्या है, इस साइड से वो नंबर डालेंगे तो इसमें ज़्यादा नंबर आएगा. तो यहाँ से ही शुरू करना होगा क्योंकि 1 2 3 4 5 यहाँ से भी शुरू कर सकते हैं, लेकिन दैट विल गिव यू द सेम कंपाउंड और द सेम पोजीशन. सो वी कैन स्टार्ट फ्रॉम हियर और स्टार्ट फ्रॉम हियर, बट वी शुड नॉट स्टार्ट फ्रॉम दिस साइड because if you start from this side, so basically this located value. So if we start like we can do like this one, this is a prime 1 2 prime 3 prime 4 prime. So this will be 4 prime, so the located value will be higher. So this number will be the correct, okay, not this. So if like this, so then what would be the name? So the root word will be the paint, and we are having substitution at 2 position. So basically name will be 2 methyl 2 methyl 2 methyl paint. ये रूट वर्ड है, हमने काउंट किया है वो जो नंबर पेंट ANE, so pentane. Okay. The same way again it can have another isomer. So basically if we change like this, so basically this is like a CH3 CH2 CH. so यहाँ पे CH3 CH2 CH3 sorry yeah. तो ये रहेगा, देखो ये जो है ये मिडिल में है, कोई भी साइड से जाएंगे तो ये जो इसका जो वैल्यू वो 3 ही आएगा. तो यू कैन डू एनी वे, इधर वे. सो 1 2 3 4 5. तो यहाँ पे क्या होगा, तो ये जो है ये है 3 मिथाइल, क्योंकि 3 पोजीशन में हमारा ये जो मिथाइल ग्रुप सब्स्टिट्यूशन है तो इसको बता सकते हैं 3 मिथाइल पेंटेन. ठीक है. तो इसका और भी पॉसिबल है, जैसे हम इसको और भी तरीका से ड्रा कर सकते हैं, जैसे ऐसे CH3 C CH3 CH3 CH2, this is CH3. अभी क्या है, तो इसमें जो दो सब्स्टिट्यूशन है तो जो अकॉर्डिंग टू द लोएस्ट लोकेटेड वैल्यू हमारे क्या होगा, तो यहाँ से ही ये शुरू करना होगा. तो 1 2 सॉरी 2, 3, 4. So this will be, no, not this. So this will be the our and 4, because now we are having total 6 carbon. So this will be our the structure, and this will be the another, chain isomer. So basically, again, if we count like this way, this side if we start, so then it will be the locatant value here will be the more. So to get a lowest locatant value, we have to start from this way. You can start from this, either from this or this, all will give the same possible, the name. Okay, so now what we'll do for this case, so at 2 position we are having 2 methyl substitution. So if we are having this kind of situation, so we can do like this. So 2 to dimethyl, 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 then total carbon root what will be 4. So basically this is butane. Okay, सो टू टू डाईमिथाइल, इसका मतलब है जो टू टू पोजीशन में दो मिथाइल सब्स्टिट्यूशन है, तो ऐसे हम मतलब यूपेक नेम से हम पता कर सकते हैं, और जो स्ट्रक्चर से हम बता सकते हैं, जो इसका जो स्ट्रक्चर आएगा ये है, नो, टू टू डाईमिथाइल ब्यूटेन। तो यही जो है, एक ही का जो कंपाउंड है, ये फार्मूला एक है, तो हम इसको कभी बुला रहे हैं hexane, कभी pentane. Again, pentane can have two types, so 2-methyl pentane, 3-methyl pentane, और इसको हम ये भी बुलाते हैं butane. So basically, depending on the substitution, so we can have a different compound. So that is why this is, now you understand why the carbon are having so many compounds. So this is, and again, these are the another example of chain isomerism. You can understand like this, and hope you understand the nomenclature of the alkane. And tomorrow or in the next class, so we'll discuss about the nomenclature of alkene and alkyne. Anyway, thank you for your kind attention.